material for today. All right, so the topic today is working with methods. In particular, what I'm going to be talking about a little bit today is interacting with objects in Java and some of the tricks and techniques that are specific to working with that particular type of data in Java. And to start us off today, I have started the beginnings of a little example program here. And in this example program, we're going to be doing some fairly typical sorts of interactions with objects in a Java program. First, a quick reminder of something that I told you about last week. Last week when we were talking about data types, I told you that every variable that you declare in a Java program has to have a data type, and data types fall into two broad categories. There are what are known as primitive types, and then there are what are known as object types. And in Java, it's very easy to tell the difference because Java follows a very consistent naming convention, and that is all of the primitive types have names that start with a lowercase letter. All right, so here is a variable whose type is int, and since the I in int is lowercase, you can tell immediately that that's an example of what's known as a primitive type. All right, now another example here is this variable, which is declared to be of type string, and since the word string has a capital S, that's a clue that this is an example of what's known as an object type. All right, in fact, the two most common object types that we've been interacting with are the string, which is used for storing text, and we've also been doing some work with the scanner, which is our basic mechanism for getting input from the user and reading any input that the user types in. All right, so today in particular, I want to focus on the object types. I want to say a little bit more about the scanner class and a little bit more about the string class. That's the main theme of today's lecture. Okay, now the first thing to point out whenever you're working with an object type is that sometimes object types will require import statements, right? And that's something that you have to do with the scanner class, for example. Whenever you declare a variable of type scanner, then you're immediately obligated to have an import statement that goes with that. Essentially what that does is that brings in the definition of what a scanner actually is, so that NetBeans will allow you to operate successfully with that particular type. Another thing to notice about many object types is the way that you initialize these object variables. The system that we used here to initialize the scanner variable is quite typical of objects, in that in most cases that when you are setting up a variable of object type, the way you initialize it is by using what's called the new operation. And here you see an example of this. This is basically a command saying that we would like to make a new scanner object. We would like to have it be reading its input from the system input. And this is very typical of the way that you create objects whenever you're working with object types. About the only exception to that is the string class. The string class is a little bit unusual. It's a little bit special in that a more common way to initialize a string variable is directly from a piece of text. This is one of the few cases where you're not going to see new being used in combination with an object type, and this is exclusively used by the string class, and no other classes behave in this special way. Every other object type, when you need to create an object, you're going to be creating it with new. All right, so now let's take a closer look at the scanner, and let's start doing some scanner typical things with it. Again, a scanner is used to read input that the user types. So what I've set up here is the beginnings of a program where we're going to need to get some input from the user. I have a couple of variables here. I have this name variable and this age variable. Neither of those variables have been given values yet, and that's on purpose because what I'm going to be doing here is I'm going to be reading the values of these things from the scanner. So let's start doing that. Let's start writing the code for reading first the person's name and then their age. Okay, now to read input, we're always going to be interacting with a scanner. And the variable in this program that actually stores a scanner object is the variable called input. And that's the thing we're going to talk to whenever we need to interact with the scanner. All right, now, the input variable is a variable of object type, and typically the most common way that you interact with a variable of object type is by using what are called methods. And the standard procedure for invoking a method is you give the name of the object you want to talk to, and then you type a period, and then after that, you type the name of the method that you would like to invoke. All right, now, what's just happened here, immediately after I typed the period, is NetBeans is offering me some very useful automatic assistance. It's basically trying to anticipate what I might do next. And the reason that this is helpful is that in some cases, and especially for the example of the scanner class, many object types provide many methods. And you're going to need a little bit of help sometimes picking out exactly the right method to use in a particular situation. And this is where this automatic suggestion feature in NetBeans turns out to be very handy. All right, so what's just happened here is as soon as I type the period, which means I'm about to give a method that we'd like to call on this object, NetBeans has popped up a series of suggestions. All right, and more importantly, these suggestions are organized in a little bit. You can see a horizontal line running across here. All of the suggestions that appear above the horizontal line, those are the methods that NetBeans thinks you are most likely to need in this particular situation. All right, and the reason that it suggested this particular set of methods is it looked at what we're trying to do in this statement. In particular, what I'm trying to do here is I'm trying to talk to the scanner for the purpose of getting some data, and then I'm going to assign that data to this variable here. And NetBeans has already seen that this variable called name is a string. So when it gives you a list of suggestions for methods you might use, it's basically giving you all suggestions of methods that produce a string as their result. Okay, now, this is still a little bit confusing because here there's a lot of options to choose from. You can probably guess that the one we want is one of these two, either the one that says simply next or the one that says next line. And in cases where you have several potential methods to choose from, another helpful thing that NetBeans does for you is as soon as you make a selection of a particular method up at the top, it gives you more information about that particular method. Now, I have to warn you in advance, a lot of this documentation information that NetBeans pops up for you is fairly technical, and in some cases, you may be able to understand clearly what the documentation is telling you. In other cases, it may seem a little bit more obscure. All right, so in this case, let's just take a guess that this first one is the one that we want. And let's see what happens if we go ahead and use that method. All right, and then to make a selection from this list, all you simply have to do is hit enter. That will enter that particular method, and then we'll go with that. All right, and then the other thing we need to do here is we need to read a person's age. So let's go ahead and get ready to do that. And again, for that, I'm going to talk to the scanner. And this time around, since NetBeans has seen that I'm trying to assign a value to an integer variable, it's going to give me a list of suggestions for a method I might use here. And it's focusing in this case on things that produce something like an integer. All right, and again, we've already seen examples of how to do this. The method that we want in this case is nextInt. So we'll go ahead and select that option to read the input that the user has typed. Okay, now, the program itself is not yet complete because I haven't actually done anything with the data that we've read here. But even so, what I'd like to do is I'd like to go ahead and run this example code basically for as much as we've written here and show you that in some cases, something can go wrong when you're interacting with the scanner. Let me show you exactly what goes wrong in this case. I'm going to go ahead and run the program. And again, it's prompting me for some input here. And I'm going to enter both my name and my age on the same line and hit enter. Okay, now what's just happened here is that something has gone wrong in the process of doing the reading from the scanner. The significant clue is the presence of all of this red text at the bottom. What's just happened is that something failed in the process of reading some of this input. And specifically what happened is that one of these commands went wrong and it generated what's called an exception. Right? So first of all, you can tell that something's gone wrong whenever you see all of this red text. And when you see this red text, the first thing to take a look at is the first line in the red text. It will tell you what precisely what went wrong here. And in this case, what it's telling us is that we just triggered an example of what's called an input mismatch exception. Okay, now something else that's useful about this information here is it's also going to tell you where exactly the problem occurred. So what you have to do is basically look down all of the blue links that appear here until you find the first link that looks like it's actually referring to your code. Right now, in the program that we're working with here, the source code file that I'm working with is called methodexamples.java. So of all the different links, the only one that's actually in my code is this one right here. And if I click on that link, that will highlight the specific line in the code where something went wrong. Okay, now the explanation for what went wrong here is a little bit obscure, but here's the explanation for what just went off the rails and what went wrong. What we did here is I did two commands to read input. The first of these commands was this one, which reads a string, but there's a subtle gotcha in how that first one works. It turns out that when you use this command, the next command, what it will try to do is it'll try to read something that looks like text, but the problem is it'll stop reading as soon as it comes to the first thing that doesn't look like text, right? So here's the input that I entered. And when you issue the next command to the scanner, what it will do is it will start reading as long as it sees text. And as soon as it stops seeing text, it simply stops. All right, so what happened here is that on line 14, when I issued the next command, what ended up being read there was just my first name. And the scanner simply stopped as soon as it reached the end of that one piece of text. Right now, because the scanner has only read my first name and it hasn't yet read my second name, that sets up trouble on the next line. Because on the next line, when I ask the scanner to go ahead and read something that looks like an integer, the first thing it's going to encounter is something that clearly does not look like an integer. And that's what triggers the problem that we see here, because we were basically asking the scanner to read an integer. What it saw instead was something that looks like text, and that triggered this so-called input mismatch exception. Okay, so the story here is sometimes when you call methods on a particular object, especially in cases like the scanner, there's always the potential that you may accidentally call the wrong method. Right now, so what's the fix for this? Well, one possible fix for this is we could recognize that most people have a first name and a last name, and we could read those as separate words. So we could do this. We could set up separate variables, one for the first name, one for the last name, and then we would basically have two separate reading commands. We would read the first name separately from the last name, again, by using the next command in both cases. And that's one way to work around this problem. And then finally, if you want to, you can do a very common trick with strings, and that is we can use the concatenation operation. In concatenation, what you do is you basically glue together other things to make a string, and that's one way that we could construct the person's full name. We could basically take their first name, and then we could add a space, and then we could add in their last name. And this is a somewhat more involved and roundabout way of getting the job done. But this now correctly uses the procedure for reading both a name and a number. All right, so let's run this and give it a shot and see if it works. Okay, so that's successful. That ran without actually generating any errors. But I would claim in this case, this is still not a perfect solution. The problem here is that some people have more than a first name and a last name. Some people have a middle name that they frequently use, and when you ask them to enter their name, they will enter actually 3 pieces of text and not 2. Right, so this is not a perfect solution. Here's another way to approach this problem, which is a somewhat better way when you're trying to read strings, and that is this approach here. What we can do is go back to just using the person's name, and the other thing we can do is we can split up the input into 2 separate parts. One part where we simply try to read the person's name, and then a separate part where we try to read their age. And for the age part, we would simply give a separate prompt for that, right? So let's just do 2 separate reads, one for the name and the other one for the age. All right, now, as we saw a minute ago, using next as a way to read a person's name doesn't work because it only reads the first part of their name. It reads only the first word. All right, well, again, in this case, the story is that, as we saw a minute ago, there are actually a number of methods we could possibly use here. And among this long list of available methods is another one, which is a better choice in this case. There's an alternative here. It's called next line. And again, the documentation is a little bit hard to understand here, but basically what the documentation is saying is that when you do the next line method, is that the scanner will read an entire line of text at once. All right, now that's exactly what we want in this case, because if a person is typing their name and their name consists of several separate words, we want to read the entire line of text that they type, so we grab their entire name all at once. That's the right solution in this case. All right, so again, as long as we select the right method and invoke the right method in this situation, that will solve our problem. All right, so let's run this again and confirm that that works correctly. All right, so that's fine. It read the name successfully, and then when it prompts for my age, that's also read successfully. Okay, now, while we're talking about things either working or not working in this example, let me show you one other useful set of tools that NetBeans provides in cases where you're not 100% certain that your code is doing the right thing. Another very powerful tool that NetBeans offers is a tool called the debugger. And let me give you a quick tour of how the debugger works and what it can actually do for you. All right, so first of all, to invoke the debugger, the first thing we do is we go into our program and we set what's called a breakpoint. The way you do that is to the left of some line you're interested in, you click in the margin. As soon as you do that, that puts a special icon in the margin and also highlights that line to indicate that there is now a breakpoint present at that particular statement in the program. Right? Now, once you've set a breakpoint, the next thing you can do is you simply change the way that you run the program. Instead of clicking the green run button, which is normal for running your program, what we do instead is we click the button immediately to its right, which is the option for invoking what's called the debugger. Right? Now, if you run your program in debug mode, what will happen is it will run until it hits the first of the breakpoints that you've set. Right? So let's do that. Let's run this in debug mode. Okay, now what's just happened is that the program is actually running. What's happened here is that because the program is waiting for some input, it's actually here on line 14. And to see the prompt and to enter our input, we have to go back to the output pane and do the usual thing of entering in our input. All right, so let me go ahead and enter my name at this point and hit enter. All right, so what's happened now is we've run past the statement where I typed that first set of input, and we're now stopped here at line 16. All right, and you can tell that we're stopped there because 2 things have happened. One is that this line is now highlighted in green to indicate that the debugger is simply stopped at that point. And also there's a little green arrow off here to the left to let you know that we're currently stopped at this point in our program. Right. Now, one other useful thing that the debugger can do for you when you're using the debugger is it also gives you a view of what's going on in your program. And that's available through this tab here. If you click on the Variables tab, what that will do is it will bring up a list of variables that are currently active in your program, and you can examine the values of these variables to see if they look right. All right, so for example, here's the name variable that we just read the input for. And you can see that the input that I typed got entered into that variable as I expected, and that has the value that I'm currently expecting to see. Right now, also you'll notice that the age variable doesn't show up on this list just yet. The reason it doesn't show up just yet is that we haven't yet given that variable a value. We're actually stopped at that statement here where the computer will read that value. And since we haven't actually read it yet, the age variable doesn't show up here. All right, so that's another useful tool for giving you more insight into what's going on in your program. And especially if you're operating in a scenario where you're not 100% confident that your program is doing the right thing, you can use this debugger facility to help you see more clearly exactly what your program is doing. Okay, now let me go ahead and stop the debugging session here. And I'm now going to add one more thing. I'm going to clear the breakpoint momentarily. I'm now going to do one more thing. One last thing to talk about here, since we're talking about objects. I've said an awful lot about the scanner class, but let me also say a word or two about the string class, because next, let's do some coding interaction with some of the strings that we've got here. All right, so you'll notice that I asked the user to enter their name here. Also, there's a second string variable in this program, is this variable called special. And the next thing I'm going to do is I'm going to basically write an if statement that checks to see if there is any relationship between the name that the person entered and this special name that I set up. Okay, now the first thing I'm going to do here is I'm going to try writing an if statement that simply checks to see if the name they entered is the same as that special name that I sort of hid in the program. And if that's the case, what I'm going to do is I'm going to do a little trick with the person's age. I'm going to magically reduce their age by 10 years. So the idea here is that if you're special, you get to be younger. But if you're not special, you get made older instead. Right? So a little simple if statement here with either a bonus or a penalty, depending on whether or not you entered the right name. Okay, and then finally, just to confirm that everything, the calculation got done correctly here, let me go ahead and put a print statement at the end. And let's use a concatenation trick to print a message that has the person's name in it, person's age in it. So we'll see what happens to the person's age after doing this. Okay, let's go ahead and run this and see what it does. Let's run it normally and see what it gives us for an output here. Okay, I've entered my name in the hopes of being special here. Oops, turns out I'm not special after all. So it looks like what happened is we hit the if statement, but instead of hitting the case that I thought I was going to hit and having my age reduced by 10 years, I actually ended up falling into the other case and with my age being increased by 10 years. All right, this is bad news. Okay, now the moral to the story here is that I just on purpose did something incorrectly in the logic of this program. The thing that I actually turned out to do incorrectly here, and the source of the trouble, is this test here. Right? In fact, this is a very common mistake that beginning programmers make. And the mistake here is that normally to test whether or not two variables are the same, we would use this double equal sign. However, there's a very subtle problem with that, and it turns out that the double equals comparison does not work for anything that's an object. Right? And that's the problem we ran into here, because both the name variable and the special variable in this example are objects. And unfortunately, the double equal comparison simply doesn't work in the case of objects. Here's what you have to do instead with objects. In objects, we use an alternative procedure that involves the use of a special method. It's called the equals method. Right? And I can type it here by starting to type it. And this is the procedure that you actually use in cases where you're trying to compare one string to another. Right? So what we actually do is we go and talk to the special string and we ask it, does your value equal the value of this other string, the person's name that they entered? And if the special object says, yes, I'm the same as this person's name, then that test will evaluate to true and the age will get knocked down by 10 years. Otherwise, the age will be increased by 10 years. All right, so let's run this and see that it now hopefully does the right thing. Yay, worked correctly. Okay, so in this case, it actually successfully determined that the name I entered is the same as the special name that we're looking for, and it fell into the right case, the case that reduces my age by 10 years. What a wonderful thing. Okay, so that's working correctly now. All right, so the moral of the story here is that when you start working with objects, you're naturally very often going to be working with methods, right? And an example of that, which is sometimes easy to forget, is that you'll even need to use a method when you're doing something like comparing two strings with each other. If you have one string and you want to check to see whether or not it's the same as another string, you actually use a method for that purpose instead of using the double equal sign. Okay, so that's the first part of today's lecture. Let me stop at this point and ask if anybody has any questions they'd like to ask about anything that I've done in the example here. If you have a question, go ahead and raise your hand and we'll answer your question. Okay, so if there are no questions at this point, let's go. I'm going to switch back over to a set of lecture notes and let's go through a few other things that I want to talk about and touch on today. All right, now, the next thing I want to touch on is that in the world of methods, there's a subset of those methods that are somewhat special, and these are what are known as static methods. All right, and let me show you perhaps one of the more important examples of a static method and explain how a static method differs from an ordinary method. Okay, now in all the examples that I just showed you, when we invoke a method, the way we do it is we start by creating a variable that has an object in it, and then we give the name of that variable a dot followed by the name of the method that we're trying to invoke. And that's the standard pattern in most cases for invoking a method on an object. Now, an alternative is that in some cases you'll invoke a method differently. And here's perhaps one of the most common examples of this sort of thing. In some cases, you're going to invoke a method by instead giving the name of a class, then a dot, and then the name of the method that you would like to invoke, right? And perhaps the most famous example of this are the so-called math methods. All of these methods are located in a special class. It's called the math class. And the way that you invoke any of these methods is you just give the name of the class, a dot, followed by the method that you would like to use. All right, so here, for example, we're using the square root function. This is how you compute the square root of 2 in a Java program. The way you do it is you invoke the math class, type a dot, and then type the actual method that you would like to use. All right, so in this case, we're not actually, in front of the dot, there's not actually a variable, there's just the name of a class. In this case, it's always going to be the math class. All right, and there are several such math methods that you may want to invoke. Here's a longer list of the available methods and what they do for you. And there are methods here available for doing most of the most common mathematical operations like square roots, absolute values, exponentials, powers, and so on and so forth. And again, you've already seen an example of this in the first homework assignment. If you finish that, in the first homework assignment, we're going to be working with math.pow. That's yet another one of these methods that are invoked in every case by giving the name of the class a dot followed by the name of the method that you're calling. So these are somewhat special. These are invoked in a slightly different way. And again, the generic term for any of these methods that are invoked by class name dot method name, these are what are known as static methods. Okay, so on occasion, we will encounter static methods and we'll be using them, and these will pop up from time to time in the course of working through examples in this course. Okay, now, one last thing I want to touch on today is another set of methods that are related to working with strings. And these have to do with, on occasion, converting things into strings. First thing I want to say about this is that one of the most common ways to convert something that is not a string into a string is to involve it in a string concatenation. And here's a very typical example. In this example, what I'm doing is I'm working with a double value. This is a number that I generated by using one of these static functions. I'm computing the sine of 1.5 radians, and that gives me a number. Now, one of the most common ways to convert a number like this into text is to do a concatenation. All right, so here I'm doing a print command, and in the print command, I'm doing a concatenation. I've got some text. I'm going to glue that together with a number, and in the process of doing this, what happens is that the number automatically gets converted into text, and that text gets combined with the other text that's here. This is perhaps the most common way to take something that is not text and turn it into text. You just involve it in a concatenation. Okay, now this is not the only way to take a number and convert it into text. There are other methods for doing this sort of thing. Here's an example of this. In this next example, I'm working again with a number. Here's a number variable, an integer n, has a value of 100. In the next line, I'm going to convert that thing into a string. And the way I'm going to do that is by using a special purpose static method. This one is invoked by giving the name of the string class. And in the string class, there's a special method called value of. And the way it works is if you give it something that is not a string, it will turn it into a string for you. All right, so in this case, we're taking n, which is an integer, and we're asking the value of method to turn it into some text for me. Right? And this trick works regardless of what data type you have. So if you have an integer that you need to convert to a string, it works just fine. If you have a double that you need to convert to a string, that also works just fine. Right? So that's an example of a static method that you can use to take something that is not a string and directly convert it into a string if you need that at some point in a program. All right, and then another example of converting the other direction, of converting from text back to something which is not text, is what the scanner typically does for you. All right, because when you're using the scanner, what's happening is that the user will be typing text in response to a prompt. And one of the things the scanner can do for you is it can take whatever text the user has typed and convert it into another type for you. Right, so in this example, where we're asking the user to enter both an integer and a floating point number, initially when the user types those things in, even though they look like numbers, they're actually text to start with. And one of the things that these methods will do is they will automatically grab the text that the user has typed and convert it into the right type for you. Right, so if the user types some text that looks like an integer, the next int method will convert it into an integer for you, which is what you want. And then if the user types some text that looks like a floating point number or a double, this method will convert that into a double for you. So there's a very common example of how to turn something that starts out being text into something that is not text. It's just, you just use the scanner for that purpose and it does the conversion for you. Right, and finally, here's another way to do the conversion. Sometimes, and this is going to be fairly rare, but sometimes in programs, you'll start out with something that is purely text, and at some point you'll need to convert that into a different type, which is not text. And for that purpose, there are further static methods that are used for that. In this case, for example, if we start out with some text that represents a number, and if we want to convert that text into an actual number, the thing that will help us do that is a static method. It's in the integer class, and it's called parseInt. And the way it works is you give it some text that represents an integer, and it will then actually convert that text to an integer for you. All right. Similarly, if you have some text that looks like a double, and you want that actually converted into a double, you have to use double, and here's turns out I made a mistake in the notes. This should actually be double.parseDouble. What that will do is take text and convert it into a double for you. All right, so yet more examples of how static methods can be used for specialized applications. In this case, converting something which is text into a different type. if you need that at some point in a program. All right, so once again, let me pause here briefly and ask if anybody has any questions over the last few slides here. Okay, we're on a roll today. One last thing I want to talk about today, the last thing I want to talk about, well, under the broad heading of methods, is there's one last class I'd like to introduce you to. This is a class we'll sometimes be using in programs, and this is what's known as the random class. The purpose of the random class is it implements what's known as a random number generator. Sometimes in a program, especially if you're implementing something like a game or a simulation, you'll need a source of randomness, and that's the purpose of the random class. It's basically designed to generate random numbers on demand. Right, and here's an example of how you use the random class. The first thing is you'll need an import statement with it. So at the top of your program, you'll need to import Java util random. Then the next step is you create a random object by doing something like this. And the main thing that the random object can do for you is you can call methods on that object and ask it to basically give you random numbers. Right? The method that you're most often going to use is the method called nextInt. What that is designed to do is it's designed to give you a random integer, and when you call this method, you have to specify an upper bound. Right? And the way that nextInt will use the upper bound is it will produce a random integer which falls in the range from 0 up to but not including the upper bound that you've given here. Right? So since we gave an upper bound of 100, what's going to happen is that this method will produce a random integer which falls in the range from 0 to 99. Right? And if that's not quite the range you want, what you will sometimes have to do is adjust it slightly. What I did here is I added an extra 1 so that now the result that we get actually falls in the range between 1 and 100. Right, so for example, if you're playing a guessing game where you want the computer to guess a random number somewhere between 1 and 100, that's how you would use the random object to generate a random integer for you to work with. All right, so and again, this is yet another class that we'll be working with from time to time. Whenever we need a source of randomness in our programs, we'll be making use of this random class. Okay, now, we're running close to being out of time for today's lecture. Again, we're going to stop at 12:15. We've got about another 5 minutes. And in the remaining 5 minutes, what I want to introduce you to is the last part of today's lecture notes. And the last part of today's lecture notes is actually set up a little bit as a reading assignment for you. And here's what's going to happen. In the final part of the lecture notes today, what I'm going to be doing is I'm going to be taking you through the construction of a somewhat longer program. And in this program, we're going to bring together a lot of the ideas that we've been talking about both last week and today. And you're going to see a lot of these ideas demonstrated in this program. Right now, first, before I try to explain any of this big chunk of text that's here, let me actually run the program that I've brought along here. We'll put away this example and open up the next example we're looking at today. In the next example, what I've implemented is a fairly long program that implements a card game. And the best way to explain how it works is to simply run it and show you what it does when the program runs. Okay, now what this program is doing is it's simulating a card game, which is very similar to the game 21, although it's a somewhat simplified version of the game 21. Right, now, the way that the game works is we have 2 players. We have a dealer and we have you. And the dealer is going to start by dealing 2 cards to themselves and you as the player. All right, so the first thing the program is going to do is it's going to show you the cards that have been dealt. So it says the dealer has dealt themselves the 9 and the 6, and the dealer has dealt you the 6 and a queen. All right, now, the next aspect of the game is that all of these cards have point values. The way that the point values work is that all of the face cards have a value of 10, and all of the number cards have a value equal to their point value. All right, and then the other thing that matters at any point in the game is each player's total number of Right, so here at this point, the dealer has a 9 and a 16. That adds up to a total of 15 points. I have a 6 and a face card. That adds up to a total of 16 points. All right, now, the object of the game here is to get as many points as you can without going over some preset limit. Right, in this version of the game, it's not quite like the 21 game. Instead, in this game, the preset limit is 17, so that if you go over 17, you lose. Right, now, what's going to happen after the cards are dealt is the program is going to ask me whether I want a third card or whether I want to stay with the cards that I have now. Now, since I'm dangerously close to going over 17, the smart thing for me to do at this point is to opt to do this and basically stick with the points that I have. Right now, once I enter my decision, the dealer will have to decide what to do. And one of the rules of the game says that if the player is ahead of the dealer at this point, the dealer has no choice but to deal themselves a third card. So let's see what happens when the dealer deals themselves a third card. Okay, so what happens is the dealer's now been forced to take another card. Not surprisingly, that next card puts the dealer over. The dealer now has a total of 24. The dealer has lost the game, and by default, I've won because I had not only the highest points, but I didn't go over the bound of 17. All right, so there's a lot going on here. There's a lot that needs to be done in this program. The program needs to use quite a number of if-else statements to make decisions at various points about what to do. We have to be dealing with cards. We have to deal with both point values of cards and text representations of cards. And there's a whole variety of things going on here. Okay, now, so this is where I'm going to leave you. I'm going to basically leave you with a reading assignment. And what you're going to do next is go to the lecture notes for today's lecture, and let's pull those up quickly and take a look at them. What I've done near the bottom of the lecture notes is when I start talking about the game here, the first thing I've laid out in great detail exactly precisely what the rules of the game are. And then I'm going to walk you through step by step through each of the key parts of the program, including how to generate a card at random, how to do things like determine the point value of a card, how to get the text representation of a card. There's code here to do that. Then later on in the program, when it comes time to start making decisions, for that, we're going to need to write some if-else statements. So here are several examples of if-else statements that implement key bits of logic throughout the program. And I'm basically leaving it as a reading exercise to you to read through these examples and try to figure out for yourself what's going on in the logic of these if-else statements, and basically practice reading some of this code and understanding how it works. All right, and finally, at the very bottom, there is a link. When you click on this, this will download the project folder for the entire program. And then the last step for you would be to open this program in NetBeans and simply read through the code of the whole thing and try to understand how it's working. This is basically an exercise in reading code and interpreting what the code is doing and seeing how this example is put together. All right, so that's your homework. Is sometime later today and over the next few days, read through the rest of the lecture notes and then read through the code of the program itself and see how all the various parts of this program are put together. All right, that's our last bit of business, is a reading exercise for you. Okay, so that's all I have for you today. One last thing before we go is to ask if anybody has any questions, anything that I didn't touch on in the lecture, or anything else you'd like to know about at this point.
I guess this isn't related to lecture specifically,
Uh-huh.
but I sent in my homework today and I could not figure out how to send in like an entire zip file. I don't know, like.
Okay, let me show you a quick example of how to do this. Let me pull up one of my projects and show you how to successfully mail in one of these things. All right, so what I'm going to do is I'm actually going to go to the card example that I was just showing you here. So that's buried deep in my lectures here. All right, so here, when you finished work, you'll have the actual project folder. Right now, actually, one thing you need to think about before you get to the project folder is in some cases, you may not be entirely sure where the project folder is. Let me show you how you can very quickly tell that in NetBeans. In NetBeans, whenever you open up a project, what you can do is you can hover the mouse pointer over the start of that project where the coffee cup icon is. And what it will do is it'll pop up a little hint showing you precisely where on your hard drive that thing is located. So if you've forgotten where you actually put the project folder, that tells you precisely where it is. So then the next thing you can do is you can navigate out to where that project folder is and locate it, and then get ready to send it in for your assignment. Okay, now the way that you submit your work is once you've found the project folder is in most operating systems, what you can do is you can right click on the folder, and somewhere in that right click menu, there will be an option to compress that. All right, I think it works largely the same way on both Windows and Macintosh. In both cases, if you right click on the folder, it'll give you the option to compress that into an archive. All right, so if I do that, that will give me the option to create a zip file from that, and that's the thing that you want to send to me. All right, so then the next thing you'll do is fire up your email client and then send me an email message and send me that zip file as an attachment to the email. Did that answer your question?
Yeah, I think so.
Okay, great.
I have another question relating
Yeah.
to that. So, do you require the zip file, or is also WinRAR okay?
I'll use any, I can work with just about any archive format. So if you're using RAR or 7-zip or any other compression scheme, that should be fine as well.
Okay, thank you.
Okay, any final questions before we wrap it up for today? All right, well, if not, I'll see some of you in lab tomorrow, and I'll see everybody else back for the lecture on Wednesday. All right, so have a good day until then.
All right, sorry, I do actually have one quick question.
Yeah.
I sent in my assignment already, but I realize now that there's one like super long line of code that I forgot to split into two. Should I fix that and send it back, or is that not something I should worry about?
Yes, this, so if you have already sent in your homework and you decide you want to make any changes, you're more than welcome to send me a later version. As long as it comes in before the due date, I will, if you, in fact, if you send me multiple versions, I will grade the last version you sent me, and that's how I'll handle that.
All right, thank you.
All right.